remote sensing satellite. Remote sensing. So let's look at the name. The remote and sensing. Remote sensing. So as the name suggests, remote means from a distance. Sensing means having a feel of it. Yeah, remote and sensing. If you so generally, how do we have a feel of it? Touch is a feel. Yeah, so that is a physical contact. So what remote sensing means is able to look at an area and make sense out of it, as in try to understand what that area is showing without physically going and touching that area. Without physically going and touching that area from a distance. And that distance can be as high as 500,000, anywhere up to 2,000 kilometers. Because India's remote sensing satellites, because they are Earth observation satellite, they are what? Earth observation satellite, which we discussed at the start, and in sun synchronous orbit, which we have again discussed, they are all remote sensing satellite. And India has a distinction of having the largest constellation of remote sensing satellites for civilian use in the world. So now the question comes, hey, if the satellite is something like 500,000 kilometers, what does it really do to make sense of the Earth? What does it do? So it can do three kinds of things. Those three kinds of things are called as spatial resolution, spectral resolution, and temporal resolution. Spatial, spectral, and temporal. Spatial resolution. What do you mean by spatial resolution? How clear the image is. We all understand spatial resolution very well. Pixel size. So when you have a mobile phone camera, you have megapixel. No? Yeah. So more the megapixel, better the resolution. Exactly the same with the remote sensing satellite. So more powerful camera it is, higher the pixel size. Now, high spatial resolution would be something like 0.4 meters. 0.4 meters means 40 centimeters. Imagine from 1,000 kilometers on top of the Earth's surface, they can take pictures which can identify an object which is as small as 40 centimeters. Imagine your scale is 30 centimeters, a little more than a scale. Okay, so that's a high spatial resolution. That's one part. So by taking pictures of the Earth, which are very high resolution, you are able to sense the Earth from remote, and that remote is few hundred kilometers. Then comes spectral resolution. This is generally the toughest to understand. So what we'll do is we'll finish temporal resolution. Temporal resolution is denotes the number of images that can be taken in a given duration. There may be applications where you need to have clicked a lot of pictures. You would have seen this in time-lapse camera and things like that. No? You need to click a lot of pictures to be able to see something happening. Yeah. So these satellites are also capable of capturing. So one, they are capable of spatial resolution, which means image quality. Temporal resolution means image frequency, means how frequently can it capture. Third thing is spectral resolution. In order to understand spectral resolution, let's take an example. Suppose there is a Earth observation satellite, and its purpose is very simple. Its purpose is to assess the forest resources of India. Okay, its purpose is to assess, let's say, the forest resource in India. And here the satellite has been given another task to identify dense forest from less dense forest. Dense forest from less dense forest. Now, okay, so this is the task given to the satellite. Now let's come to the definition of spectral resolution. What are we saying? Spectral resolution means ability to identify the smallest difference in the wavelength. Per se doesn't make sense. Sorry, what is this here? Smallest So,